Hello everyone. On this video we will be looking at solving right triangles by using our trigonometric functions, or our three main trigonometric functions. Okay, so if you remember SOHCAHTOA, sine equals opposite over hypotenuse, so CA, cosine equals adjacent over hypotenuse, and the TOA is the tangent equals opposite over adjacent. Okay, so remember, if this is your degree or your angle, the opposite is over here, and the adjacent is right here. Okay, now if your angle was up here, then your opposite would be on this side and your adjacent would be here. Okay, your hypotenuse is never your opposite or adjacent. Your hypotenuse is the hypotenuse. Okay, the opposite or adjacent will always be one of the two legs that connect the right angle. Okay, so what if you know the value of sine of x and your opposite? Okay, so if that's the case, you can use sine of x equals the opposite over the hypotenuse to solve for the hypotenuse. Okay, so if we have sine of x equals the opposite over the hypotenuse, what if you multiply both sides by the hypotenuse? And we there we go. So that would give us, let me move this up a little bit, the hypotenuse times sine of x is equal to the opposite over the hypotenuse times the hypotenuse. And if you notice, these two would cancel out. So that gives you the opposite equals sine of x over the hypotenuse. Now what if we get here and we divide both sides by sine of x? Okay, so you have sine of x divided by sine of x. Okay, so these two would cancel out, and you'd end up with the hypotenuse equals the opposite over sine of x. All right, so you can do that to solve for the adjacent. You can do that to solve for the hypotenuse. You can do that to solve for your angle. All you have to do is figure out what you have and what you're solving for. Okay, so any missing side or angle, you can use this very same technique, not just for the hypotenuse, but also for the opposite. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next page. And this question here, so let's say find the missing quantities, round all sides to the nearest tenth. Okay, so let's say we know that this angle is 51 degrees, and we know this side is 6 feet. But this side x and this side y, we don't know them. Okay, so we can't use the Pythagorean theorem to find out the length of these two sides because we only have one side. We'd need at least two of the sides to use the Pythagorean theorem. But we do have an angle, which means we can definitely solve this. Okay, so to solve this, so we know the angle is 51 degrees. And now this is our angle, which means this side is our opposite. The opposite is equal to 6 feet. Or we can just put 6. Okay. Now, if we have the angle and we have the opposite, How do we solve it? Well, you have to ask yourself what trig functions have an opposite. Well, there are two. We have tangent of x equals opposite over adjacent, and we have sine of x equals opposite over the hypotenuse. Okay. Well, the only thing is we can't use this one because we have an opposite, but we don't have an adjacent. So we can't use this one. Okay, but we can't use this one. Now, we could use this one once we find out the adjacent, but for right now, we can't start with this one. Well, actually, we could. We could have started, but we're not going to. We're going to start with this one. Okay, but we're going to solve for the hypotenuse. Actually, we could have started with this one, but we're not going to. All right, so if we did do this one, okay, we know that in this case, our angle x equals 51 degrees, and our opposite is equal to 6 feet. So we're going to go ahead and plug that in. Okay, so we have sine of 51 degrees equals the opposite over the hypotenuse. Okay, let me kind of separate that. Okay, so we have to multiply both sides by the hypotenuse. So we have the hypotenuse times sine of 51 degrees is equal to 6. Because the hypotenuse, when we multiply it on this side, will cancel out. So now we divide both sides by sine of 51 degrees, and we see the hypotenuse is equal to 6 divided by the sine of 51 degrees. Okay, so now what we do is we go ahead and we plug this into our calculator. 6 divided by sine of 51 degrees. And you should have ended up with 7.72056. But since we're rounding to the nearest tenth, it's 7.7. Okay, so that's our hypotenuse, which is our y. All right, so now that we know our y, I'm just going to do a quick sketch of the graph just to show us. So we have 51 degrees, 6 feet, and our hypotenuse is 7.7. And this is x. Okay, now if you wanted to, you could use tangent of x to solve for the adjacent, because you have the opposite and the adjacent. But what we did was we did the sine to do the opposite over the hypotenuse and solve for the hypotenuse. Okay, but what we're going to do here, we're going to go ahead and use the Pythagorean theorem. And like I said again, if you wanted to, you could use the tangent, which is opposite over adjacent, and solve for the adjacent. But we're going to use the Pythagorean theorem here. Okay, to solve for side x. Okay, move this up. So you have x squared plus y squared equals z squared. Okay, so to solve for x, x is equal to the square root of z squared minus y squared. Okay, now remember the z is your hypotenuse. So that's going to equal the square root of z squared, which is 7.7 squared. Well, we won't use the rounded, we'll use that for a more precise answer. 7.72056 squared minus your y squared, which is 6 squared. Okay, so if we plug that in, we get approximately 4.85871 feet, but we want to round that to the nearest tenth, so our x will be approximately 4.9 feet. All right, and that's how you would solve that one, or one method of solving it. Remember, there are multiple methods that you can use to solve this. Okay, that just happens to be one. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so for all the missing quantities, find all the missing quantities and round all angles to the nearest minute and sides to the nearest tenth. Okay, so you have a right triangle with 22 feet, 14 feet, your missing angle, and your missing hypotenuse, which is your x. Okay, so what I want you to do is go ahead and press pause and see if you can figure out this one on your own. All right, so assuming you have pressed pause, let's go ahead and verify. Okay, so we have our angle here. This is our angle. We know our opposite. Is equal to 14. So we have our angle and we have our adjacent. Equals 22. Okay. Now, what trig function has an opposite and an adjacent? It's tangent. Tangent of our angle A is equal to opposite over adjacent. Okay. Now, we don't know what our angle is, but we do know that we can use inverse functions. Okay. So all we have to do is solve for A. Okay. So tangent of A is equal to opposite, so 14 over 22. Okay, and if you plug 14 divided by 22 in the calculator, you get tangent of A is equal to 0.636364, and it keeps on going, but that's good enough for now. Okay, so for this, we apply our tangent inverse to both sides. Okay, so we end up with, let me move this over a little bit, tangent inverse of tangent A equals tangent inverse of 0.636364. Remember, the tangent inverse and tangent cancel each other out. So you end up with A equals the tangent inverse 0.636364. So if you plug that into your calculator, you end up with A equals 32.4712 degrees. So let me clean up that a little bit, which is fine, but this has to be rounded to the nearest minute, which means we have to change that part of it, our decimal part, to minutes. And we can do that right over here. Okay, so 0.4712 degrees divided by 1. Remember, 60 minutes is equal to 1 degree. So 1 degree is equal to 60 minutes, where our degrees, unit of measure, cancels out. So you get 0.4712 times 60, you end up with 28.272 but we want to round that to the nearest minute. So that would be approximately 28 minutes rounded. Okay, so A is equal to 32 degrees and 28 minutes. Okay, so we found our angle A. All right, so now what we're going to go ahead and do is we're going to use the Pythagorean theorem to solve for our x. Okay, remember when I told you on the previous video, don't get too caught up on the variables. Okay, it won't always be x squared plus y squared equals z squared, or a squared plus b squared equals c squared. Sometimes to avoid confusion, you do have to use the variable that's given. So you can say our Pythagorean theorem, a squared plus b squared equals x squared. Again, the variables are just letters. That's it. So these are the legs, and this is our hypotenuse, x. So we know, since we're solving for the hypotenuse, x will equal the square root of a squared plus b squared. Okay, just so we don't have to keep scrolling up and do a quick sketch here. So you have 22, 14, and we already solved for our a here, but I'll just put a there. Okay, so you have your a and your b. So it's going to equal 22 squared, or the square root of 22 squared, plus 14 squared. Okay, so that's going to equal the square root. 22 squared is 484, plus 14 squared, which is 196. And if you plug that into your calculator, you will end up with 26.0768, which rounds to about 26.1 feet. And that's your side x, or your hypotenuse. All right. So if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example, which states that find the missing quantities, round all sides to the nearest hundred. Okay, so you have 24.5 centimeters here. You have 47 degrees here for your angle, and you are missing your y leg and your hypotenuse x. So go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've paused it and worked it out. So let's go ahead and verify. Okay, so what do we know? Well, we know that your angle is 47 degrees. Since this is your angle, we know that this is your opposite. So your opposite is 24.5. Okay, so we have our angle, we have our opposite. Well, we'll go ahead and use sine of our angle is equal to opposite over hypotenuse. And you notice here, I didn't use sine of x. You can, but I don't want to confuse it with this x that we're solving for. So I just replace x with sine of a. Like I said, you do not have to be handcuffed to a particular variable. You can make your angle a, you can make it x, you can make it any variable that it leads to the least amount of confusion. Okay, so again, we're solving for the hypotenuse. So if we multiply both sides by the hypotenuse and divide sine a on both sides, we get the hypotenuse is equal to the opposite over sine of a. Okay, so that's going to equal 24.5, since that's your opposite, over sine of 47 degrees. And if you plug that into your calculator, you get 33.4995 centimeters, but we want to round it to the nearest hundredth, so that's going to be 33.50 centimeters. And that's your side X rounded. Okay, now what we're going to do is we're going to go ahead and solve for our side Y. And I'm going to do things a little different. I'm going to show you two methods to solve it and show you how you're going to get the same answer no matter which one you picked. Okay, so I'm going to go ahead and just do a quick copy sketch of that graph. It's not going to be perfect, but so we have 24.5. Our hypotenuse is 33.5, and we're missing side Y, and our angle is 47 degrees. Okay, so just did that so I can scroll up and you can still see what we're doing. Okay, so you can use, because we have our angle and we're looking for the adjacent, we can have cosine of 47 degrees equals the adjacent over the hypotenuse. And then we solve for the adjacent. We see that our adjacent equals, we multiply both sides by the hypotenuse. Cosine of 47 degrees times the hypotenuse. Okay, so we know our hypotenuse is 33.5. So that's cosine of 47 degrees times 33.5. Okay, you plug that into your calculator, you get approximately 22.8469, but we want to round it to the nearest hundredth, so it's 22.85 rounded. Okay, now you can do that, or you can use Pythagorean theorem. Okay, so you have your Pythagorean theorem, which is b squared plus y squared equals x squared. And remember, you can use any variables you like because we're solving for the y. That's why I used it here. But we're solving for the y, so we have to isolate that. So in this case, your b is equal to 24.5, and your hypotenuse x is equal to 33.5. Okay, so since we're solving for side y, that's going to equal the square root of x squared minus b squared in this case. So that's going to be the square root of 33.5 squared minus 24.5 squared. Okay, so if you plug that into your calculator, you end up with 33.5 squared, which is 1,122.25 minus 600.25. Okay, which ends up being the square root of 522. Plug that into your calculator, you get approximately 22.8473, which ends up being 22.85 rounded. Okay, so as you can see, your exact value will be different by a few decimals. Like really the maybe 100th or 1,000th position decimals. But overall, your answer will be pretty close to being the same. And when you round it, it ends up being exactly the same. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so find the missing quantities, round all sides to the nearest hundredth. Okay, so this side is 23.62 inches, and your angle is 56 degrees 18 minutes. Okay, let me write that a little bit bigger. So 56 degrees 18 minutes. Okay, so that's your angle, in case you can't read that. Okay, so we have side X, which is your hypotenuse, and side Y. So what I want you to do is press pause and try to solve it on your own. Alright, so assuming you've paused it, so let's go ahead and verify. Okay, so we know our angle is 56 degrees 18 minutes, and your opposite is 2362, because your angle's here. That, of course, is your opposite. Your Y is your adjacent. Okay, now, first thing you want to do, if you have a calculator that measures in degrees and angles, you're fine, but if you don't, you want to convert this just to degrees, which means you have to get rid of that 18 minutes. So 18 minutes over 1 times, you want to get rid of the minutes, so you have 60 minutes equals 1 degree. And your minutes cancel each other out. So it's going to be 18 times 1 over 1 times 60. 18 divided by 60, you end up with 0.3 degrees. All right, so if we replace this, (56.3 degrees). All right, so now we just have to solve for our missing sides. We have the opposite, so that means you can use sine of A is equal to opposite over the hypotenuse, or tangent of A equals opposite over adjacent. Okay, so I'll start off with this one. Well, really it's not an or, it's an and or, because I'll show you in a second that we're going to use both of these, or you can use the Pythagorean theorem, but we're going to end up using both. Okay, so we're going to solve for the hypotenuse. So we're going to multiply both sides by the hypotenuse and divide by sine of A. So we see that our hypotenuse is equal to the opposite over sine of A. Okay, so we see here our opposite is 23.62, and our sine of A is just sine of 56.3 degrees. Okay, so if you plug that into your calculator, 23.62 divided by sine of 56.3 degrees, you end up with approximately 28.391 inches. But we want it rounded to the nearest hundred. So our x is going to be, which is our hypotenuse, is going to end up being 28.39 inches when rounded. Okay, so do a quick sketch of our graph so we can scroll up. So we have our x, which is 28.39. I'm going to go ahead and write that. 28.39. We have our y that we're solving for. And we have 23.62. And we have our angle, which is 56.3. All right, so now we have to solve for our y. And once again, you have options. You can use tangent of A equals opposite over adjacent, or you can use the Pythagorean theorem. Well, honestly, we've used the Pythagorean theorem a couple of times, so I'm going to show you how we're going to do this. Like I said again, you will get the same answer either way. Okay, so if we use this, we multiply both sides by the adjacent, and then divide both sides by tangent of A, we get the adjacent is equal to the opposite over tangent of A. Okay, so we know this is our angle here. Our opposite is 23.62. And our adjacent is, well, not our adjacent, our tangent of A is tangent of 56.3 degrees. Okay, so if you plug that into your calculator, you get approximately 15.7526 inches. Okay, so if we round it to the nearest hundredth, we get our y, which is our adjacent, is equal to approximately 15.75 inches rounded, when it's rounded. All right, so if you're still writing, feel free to pause it and catch up. But we're going to go ahead and move on to our next example. A good old-fashioned story problem, or application as they like to call it. Okay, so what if you have a helicopter flying directly over a fishing boat at an altitude of 1,200 feet, spots an ocean liner at a 15-degree angle of depression. So if this is your helicopter, it looks 15 degrees down, and it spots an ocean liner, and it's directly above a fishing boat. How far from the boat is the liner? Okay, now what I want you to do is go ahead and press pause and try to solve this one on your own. Here's a hint. Try drawing an angle, or basically draw this shape. Draw the shape that you're looking for. Okay, so go ahead and press pause and try this one. All right, so I'm assuming you've paused it, so let's go ahead and verify. Okay, now the hint was draw the fact that this looks like a right triangle. So we're going to go ahead and redraw that, since the helicopter and the fishing boat are 1,200 feet apart, and this is your ocean liner. And they want to know how far is the boat from the liner. So the boat from the liner is C number of feet, because this is 1,200 feet, so we're assuming that it's going to be in feet. Okay, so since it's at a 15-degree angle of depression, we know we can have our 15 degrees here, and 1,200 is our opposite. Okay, so we know our angle equals 15 degrees, and our opposite equals 1,200. Okay, Now we can go ahead and use tangent. Tangent of A equals opposite over adjacent. Now we could have used cosine if we wanted to, adjacent over opposite, but we're going to mix it up a little and use tangent. Okay, so we're going to use that to solve for side C. Okay, so if we have tangent of A equals opposite over adjacent, we're solving for the adjacent. So our adjacent is going to equal the opposite over tangent of A. Because remember, all we did was multiply both sides by the adjacent, then divide by tangent. Okay, so that means it's going to equal, move this up a little bit, the opposite, which is 1200, over our tangent of A, which is tangent of 15 degrees. Plug that into your calculator, you end up with approximately 4478.46 feet. 4,478.46 feet. But you want to round it to the nearest foot. Round to the nearest foot. Just to give a nice simple answer. So that's going to be 4,478 feet rounded. All right. So remember, when you're doing an application problem like this, just draw the shape that it mimics and you'll be able to solve it. All right. So hopefully this all made sense, and I will see you on the next video.